Welcome to Math Points, and today I am trying to teach you the tracing of a Cartesian curve. Okay, how we tracing a curve of a graph given by a parametric equation. Okay, so the following points are helpful in tracing of a Cartesian curve. There are the 6 steps we have to do in every examination where the questions are given, and according to these steps we have to solve the questions. So now we start the steps. The first property is symmetry. We have to start with symmetry. We have to see the symmetry of a curve. Okay, so in a symmetry, as we know that the Cartesian curve means the relation between the x and y, the relation between the x and y. So the every Cartesian curve where is a relation between the x and y. So the first step is symmetry, and in symmetry a curve is symmetrical about the x-axis if all the power of y in the equation of the curve are even for y equals to 4x. This property says that for any curve, like for example any curve, this is the equation of the parabola, so we have to draw the parabola, and this symmetry means any figure which we have given any figure, and when we divide this figure in half, so this is equals when the curves parallel to the x-axis are flapping, then it is covered the negative y-axis, negative x-axis part. So the point is that a curve is symmetrical about the x-axis if a curve is symmetrical about the x-axis if all the power of y in the equation of the curve are even for y square equals to 4ax. This point says that clearly says that a curve is symmetrical if a curve is symmetrical. This is a curve of a parabola about the x-axis if all the power of y in the equation, this is the equation of the parabola, and if all the power of y in the equation of the curve are even for y equals to 4ax. Okay, so there in symmetry there are the 4 points. There are the 4 points which are given for solving this, for determine the symmetrical criteria. So the second point is this. Second point is that a curve is symmetrical about y-axis if all power of x in the equation in the given curve are even. For example, x square equals to 4ay. Okay, so this is the parabolic equation, and this is the curve that is known as the x square equals to 4ay. This is parallel to the y-axis. Okay, so there are 2 points. A curve is symmetrical about the x-axis if all the power of y in the equation of the curve are even for y square equals to 4x. And second point is that a curve is symmetrical about y-axis if all the power of x in the equation in the given curve are even. For example, x square equals to 4y. As you know that the parabolic equation says that x square equals to 4ay, x square equals to 4ay, and the y equals to 4ax. This is the parallel to the x-axis, and this is parallel to the y-axis, and so we can say that this is the symmetrical about the y-axis, and this is symmetrical to the x-axis. So this is the third points of the symmetry symmetry of a curve. How we determine a curve is symmetrical. So we have to see that this in symmetrical, how a curve is symmetrical. We have to see that this point is applicable for this curve. So this point is say that the curve is symmetrical about the line y equals to x if the equation of the given curve remains unchanged on the interchanging x and y. For example, x square equals to y square equals to a square. This is the equation of the circle. So this point says that a curve is symmetrical if a curve is symmetrical about the line y equals to x. So if we draw y equals to x equation, if we draw the y equals to x equation, when a curve is symmetrical about the line y equals to x, if the equation of the given curve remains unchanged, if the equation this is the equation x square plus y square equals to a square, if the equation of the given curve remains unchanged, if the equation remains unchanged on the interchanging x and y, if we change the value of x and y, this equation does not change the property of the equation of a circle. Okay, so the curve is symmetrical about the line y equals to x if the equation of the given curve remains unchanged on the interchanging x and y. Okay, so the third point is the third point of a symmetrical, to determine the symmetrical of a curve is that, fourth point is that if the equation of a curve remains unchanged, if equation of a curve remains unchanged, this is the equation, this is the equation of a circle, and if the equation of a curve, this is the equation of a curve, and if the equation of the curve remains unchanged, okay, when x is changed to minus x and y is changed to minus y, then the curve is symmetrical in opposite quadrant. Okay, so when we draw a curve according to this equation, and when we change the when we change the value of x into minus x and y is changed into minus y, then the curve is symmetrical in opposite quadrant. Okay, now the second step for tracing of a curve are origin and tangent. We have to see that the origin and tangent of a curve for tracing. Okay, so the point is that if the point 0, 0 satisfy the equation for the given curve, then the curve passes through the origin. This point says that if the points 0 and 0 satisfy the equation for the given curve, then the curve passes through the origin. Okay, now next point is that if the curve passes through origin, if the curve passes through origin, we check the nature of origin, that is node. We check the nature of origin, that is node and cusp. Okay, these are two terms. Now we define these two terms after that point. Now, so if the curve passes through origin, if the curve passes through the origin, okay, we check the nature of origin, that is node and cusp. We have to check the node and cusp. Okay, for this we find the tangent at origin. We find the tangent at origin by equating the lowest degree term to 0. Okay, by equating the lowest degree term to 0. So for example, as you see, let x square plus y square plus x plus y equals to 0. So this point is say that we have to see the lowest degree term of the 0. So highest degree is 2 and the lowest degree is 1. Okay, we have to take this value because this it has power of 1, so we have to take the lowest degree. Okay, so x plus y equals to 0, so x equals to minus y. Okay, now the third point is that if we get two tangent at origin, then we find its nature. Okay, so this point says that if we get the two tangent at origin, then we find its nature, that how the nature of a curve is that, question mark. So if we get two tangent at origin, okay, then we find its nature. Now they are following condition to check the origin and tangent property. So our second step is that origin and tangent. So we have to, they are following steps so, like the symmetrical. Following steps that is determined to how check the origin and tangent property. Okay, so the first property is for condition is that if both tangent are real, and its instant, then origin is called node. So we have to see that in the previous points of the origin and tangent, if the curve passes through the origin, we check the nature of origin, that is node and cusp. Okay, so node is that if the both tangent are real, tangent are real and its instant, then origin are called the nodes. And the second point is like the cusp. So the node is that let the curve is like this, okay, and a straight line of equation y equals to x, it passes through the origin, and this makes the nodes. This is called the node. So the B points is that, B condition is that, condition B is that if both tangent are real and coincident, then origin is called a cusp. For example, like this, cusp is like this. Let a curve is like so, the curve, and this is the tangent. Okay, now the cusp, the slope is like this, and so the cusp is that points. So the cusp is that point. Next condition of the origin and tangent is that if the both tangents are imaginary, then origin is called isolated points. Okay, like this, we have to learn how this property, how the condition is determined. If the both tangents are imaginary, if the both like a curve is like this, okay, and if the both tangent are, if there is a tangent and there is a tangent, okay, if the both tangents are imaginary, then origin is called the isolated point. Let this tangents are imaginary, so these points are known as isolated points. So these points are called the isolated point. So the third step is that the point of intersection of curve with coordination axis. This is the third steps to determine the tracing of a curve, okay, of a Cartesian equation. So the third step is that point of intersections of a curve with coordinate axis. So the point is that put x equals to 0 and y equals to 0 in the equation, okay, of the curve. Put the x equals to 0 and y equals to 0 in the equation of a curve, respectively. It gives point of intersection of the curve on y-axis and x-axis, respectively. Okay, so we have to draw a curve that if this is the y-axis and this is the x-axis, so put x equals to 0 and y equals to 0 in the equation of a curve. If our equation is given in which the x equals to 0 and y equals to 0 in the equation of the curve, putting respectively, it gives the point of intersection in the point of intersection of the curve on the y-axis and x-axis respectively. This is the point of intersection of the curve of y equals to 0 and x equals to 0. Okay, this is the x equals to 0, so point is that 0 and y equals to b, so 0 and b, and if x equals to y equals to 0, so the point is a and 0. Okay, a new term are given in the step of tracing of a curve are asymptotes. Asymptotes is the state is defined as a straight line at a finite distance. A straight line at a finite distance from origin to which the curve doesn't intersect it and touches it at infinitely. It means that the asymptotes is a boundary line or the limiting line for the curve. So this is the fourth step, and in fourth step we have to determine for tracing of a curve is asymptotes or not. Asymptotes is defined as a straight line at a finite distance from origin, okay, to which the curve doesn't intersect it and touches it at infinitely. It means that the asymptotes is a boundary line or the limiting line for the curve, okay, like this. If a curve is parallel to the y-axis and x equals to a, then these line are going to infinitely and this is a straight line at a finite distance from origin to which the curve doesn't intersect it and touches it at infinitely. It means that the asymptote is a boundary line or the limiting line of a curve. So there are following conditions to determine the following curve are asymptotes or not. So the following condition, there are two conditions and are not in the asymptotes which are used to determine the following curves are asymptotes or not. So the first condition is that asymptotes parallel to x-axis, that is the equating the coefficient of highest power of x to 0 in the given equation of curve. This point says that asymptotes parallel to x-axis means the straight line are parallel to x-axis, equating the coefficient of highest power of x to 0 in the given equation of the curve. There is a lot of theory parts in this concept, and when we solve example, then you are easy to understand the theory part. So only reading 3 to 4 times of this theory part, and then understanding to this theory part. Okay. So the fourth step is that the asymptotes, and this is the condition of the asymptotes to determine how we determine the asymptotes. Asymptotes parallel, when the asymptotes parallel to x-axis, equating the coefficient of highest power of x to 0 in the given equation of curve. Now the second condition is that asymptotes parallel to y-axis means equating the coefficient of highest power of y to 0 in the given equation of curve. So the two conditions are given by which we determine the asymptotes property. Okay. Now there is a note in asymptotes that it is not necessary that every curve has asymptotes. For example, the curve x square plus y square equals to a square has no asymptotes. Okay. So this is the important notes of to determine the asymptotes property. Now the fifth steps of tracing of curve is given. This is the region. After the fourth step, there we have to do the fifth step, that is we have to determine the region, how a curve are going to a region. Okay. That is the how a curve are cover a part of area of a region. Okay. So this region says that to find the region of the curve, we solve the equation of the curve for the y or x, whichever is convenient, whichever is convenient. So now suppose we solve the equation of curve for y. Then we examine the following points, or condition. We examine the following condition. So now we read the following condition of a region, like the previous steps condition. So now we have to read the following condition of a region, how we determine a region of a curve. So the region is said that to find the region of a curve, we solve the equation of a curve. So we have to first solve the equation of a curve of every figure, geometrical figure, for the y or x, whichever is convenient. Suppose we solve the equation of a curve for y, then we examine following points of condition. When we solve the equation of a curve, then we have to examine the following points of the following points or conditions. So the points is that. We have to find those value of x for which y is tends to infinite. This is the points of a region to determine a region, how far a curve is going. This is the points. This is the condition, points of a region. After the solve equation of a curve, we have to examine following points or condition of a region. So the first condition, points, is that we find those value of x for which y is tends to infinite. Okay. Now the second point is that we have to find the interval. We have to find the interval for x in which the value of y becomes imaginary. So we have to determine the value of x in which the value of y becomes imaginary. So the second point to determine the in region parts is that we have to find the interval of x in which the value of y becomes imaginary. So the third point is that we find the interval for x in which the value of y either increasing or decreasing, etc. So there is 3 points, and the third point is that we find the interval for x in which the value of y either increasing or decreasing, etc. So we have to given the interval. We have to find the interval. We have to find interval for x in which the value of y either increasing or decreasing. Y part is increasing or decreasing, and the interval of x is we have to find. So this is the 3 points of the region parts, and now we have to go special points. Special points is that if a question is given in university exam or in any exam, we have to solve the fifth 5 points, and if we have in 5 points compulsory, and the special points, 6 points, this is the 6 points. Special points, it means the step 6 we may do, and we may not do the special points, step 6 and the steps. Now we have to go in the step 6. Now the step 6 and step 6 is the special points. There the compulsory points are 5, and we have to we may do the 6 points, 6 steps, and in 6 steps there is special points, and the points are not that the find the dy by dx by the equation of curve. We have to given the equation of a curve, and by this equation of curve we have to determine the dy by dx. And how we determine the dy by dx? After that, after that determining the dy by dx, we have to following steps. Following condition is that if dy by dx equals to 0 for some value of x, then the tangent is parallel to y-axis. Then the tangent is parallel to y-axis, like this. If so, the point is say that, so the condition is say that if the dy by dx equals to 0, dy by dx means the differentiation of the y equation of a curve with respect to the x. So find the dy by dx by the equation of the curve, and we have to examine the following condition. And the condition is that the dy by dx equals to 0, if the differentiation of the equation curve of 0 for some value of the x, then the tangent is parallel to the y-axis. So like this. Okay, x1 and x2. Okay, now the second point, now the second condition we have to examine for the special points is that if dy by dx tends to infinite for some value of x, then tangent is parallel to y-axis. Means that, like the previous condition, this is the parallel to the x-axis, and if the tangent is like this, so the curve is like this. Okay, and the third condition of the special points is that if dy by dx is positive for some interval, if the dy by dx is positive for some interval of x, then curve is increasing in this interval. Like this. If a curve is like so, when we draw a tangent, and the angle forming by the tangent is always less than the 90 degree. Okay, and theta is always less than the 90 degree. Okay, every theta is every angle which of the tangent is less than 90 degree. So this point is say that if the dy by dx is positive for some interval of x, then curve is increasing in this. So the fourth condition of the special points are that if the dy by dx is negative for some interval of x, then curve is decreasing in this interval. So like this, if a curve is like this and going to parallel to the x-axis, let y equals to fx, then if we draw a tangent, then this angle is greater than is 90 degree, and so the tan 90 degree plus theta equals to minus cot of theta. So this condition is says that if dy by dx is negative for the some interval of the x, then curve is decreasing in this interval. So the minus denotes that the curve is decreasing and parallel to the x-axis. And this point says that if dy by dx is positive for some interval of x, then curve is increasing in this interval. Increasing in this interval. Theta is always less than 90 degree. Okay. So we have to. So I repeat this property, and we have to. There is a lot of theory part in this concept. So you have to read, and any place of this concept you have if any problem, then you reply me in the comment box. Okay. And now after that we have to solve the many example related to the tracing of a curve concept, and we have to examine the following steps, and understanding is clearly by solving the example. Okay, by solving the example. So if you really like my voice and my understanding capacity, then please share, like, and subscribe my channel. This is my first English understanding of a concept. So I am trying to learn in English, and so this is the. So we have to arrive down the first concept of a tracing of a Cartesian curve. Thank you, and